Alright, so in this video, we are going to go over increasing and decreasing functions. So increasing and decreasing functions. So first of all, let's look at increasing functions. So an increasing function, so by definition, and a function is said to be increasing. So a function f is increasing. So basically when I say a function f, that means f of x or f of any variable, right? A function f is increasing if for a less than b, f of a is less than f of b within a given interval. So basically the idea is when we consider an interval, so an interval, a closed or open interval of some input values, right? So when we consider this interval, if you put a smaller value, a less than b, so a is smaller than b, if you put a smaller value inside the function, the output is smaller than when you put the bigger value, right? So output of the smaller value is smaller than the output of the bigger value. That is the idea. Right, so a function f is increasing if for a less than b, f of a is less than f of b within a given interval, right? So basically, that is the idea of for an increasing function. And the idea is that for this interval, f dash of x is going to be positive. So for a function to be increasing, the derivative of that function is going to be positive, but it's going to be positive within that interval. That is the idea. So let's look at a decreasing function, and it's exactly the opposite. For a decreasing function, a function f is set to be decreasing if for a less than b, f of a is bigger than f of b. So you put a smaller value, right? The output is bigger than the output for the bigger value. So that is a decreasing function within a given interval. So the idea is that f dash of x is going to be negative, or dy by dx is going to be negative. So now let's look at this diagrammatically, right? So let me draw an increasing function, something like this. Now, how do I know that this is increasing? Well, let's look at A, and let's look at B, right? And let's look at f of A, and let's look at f of B. And this is the function f, right? Then we see that if I put, when A is less than B, right? Because this is the positive x-axis. So for A less than B, we see that the output f of A, this output corresponding to A, is less than the output corresponding to B. So f of A is less than f of B for A less than B. So this is an increasing function. Now let's look at the first derivative, dy by dx. The first derivative is basically, this is the slope, right? The first derivative is slope at a particular x. Slope or the gradient at a particular x value. So let's look at the slope at a particular value. And to do so, we have to reintroduce the idea of tangent lines, right? The slope is given by the tangent line at that point. So at this point, this is going to be the tangent line. And remember, the tangent line is the line that cuts the curve at only once at that given point. The tangent line here is going to look something like this. The tangent line here is going to look something like this. The tangent line here is going to look something like this. I'm so sorry, my lines are bad, but you get the idea. And if you want the slope here, this is a positive slope, right? Remember your straight lines. This has a positive slope. This also has a positive slope, right? This has a positive slope. This has a positive slope. This. So all the purple straight lines that we can draw have positive slopes. And that is the straight slope of the straight line. So if you remember your straight line chapters, these are all positive slopes. So that is why dy by dx, which is the slope at a particular point, is going to be positive for an increasing function. And the same logic applies for a decreasing function. So if I draw the axes here, so let me draw a decreasing function, something like this. And now you can check, right? You check 2 points, A and B. And you see that for A less than B, because it's on the positive x-axis, right? So A is less than B. You have f of A is bigger than f of B. All right. And now, let's look at dy by dx. Remember, dy by dx is just slope at a particular x value. So the tangent line here and the tangent line here, look at the slope of these tangent lines, right? That is going to give some information about dy by dx. These are negative slopes. Remember your straight line chapters. If your slope is in this direction, it's negative, right? If your line looks like this, it has a negative slope. If your line looks like this, it has a positive slope. So you can see that the gradient here is obviously negative. So that is why dy by dx is less than 0 for a decreasing function. All right, so that is all that we need to know. So the information that we are going to use most is actually this one. So for a decreasing function, dy by dx is less than 0. For an increasing function, dy by dx is greater than 0. So now, if I draw something like this function, right? So this is like x squared plus 1, if this is 1. So in this function, so I'm so sorry about this. Okay. If you draw your tangent line here, right? If you draw your tangent lines after x is equal to 0, so at x is equal to 0, your tangent line is going to be flat. So at x is equal to 0, dy by dx is going to be 0, right? For x bigger than 0, if you go this direction, your dy by dx, your first derivative, the slope of the tangent line is positive. And if you check for x less than 0, so if I draw my tangent lines here, you're going to see that you have negative tangent lines, right? So for x less than 0, dy by dx is negative. So now we are going to solve for these intervals. So most of the questions that we are solving for will actually require us to find the intervals. And dy by dx is equal to 0. So this is like where we have a local maxima or minima point. So a local maxima or minima point occurs when dy by dx is equal to 0 or it is undefined. But we will discuss that later. But for our grade level, dy by dx usually indicates a local maxima or minima. And that is something that we need to keep in mind. All right. And after this maxima or minima, see, if you think about it, dy by dx will see a sign change. So if I draw this dy line for dy by dx, at 0, dy by dx is 0, right? This is x, by the way. On my blue line, I'm plotting x. So dy by dx is equal to 0 when x is equal to 0. When x is positive, bigger than 0, dy by dx is bigger than 0. When x is negative, dy by dx is less than 0. So we are going to figure this out for most of the questions. And if you think about it, right, here the function is decreasing. Then the tangent line has 0 gradient, and then it starts increasing. So think about it. Your function is decreasing, decreasing, decreasing. Your tangent line becomes flat, and then your function starts increasing. So this information also helps you to draw, sort of get an idea of how your function looks like, right? So your tangent line, so you just want to imagine drawing tangent lines to this shape, and you can see that this satisfies the information given here, right? It's decreasing, the function, my f function is decreasing, and then it becomes, the gradient becomes 0. So the tangent line has a 0 gradient here. Then it starts increasing. So my graph should look like this. So you can get an idea of how your graph looks like. And at this point, dy by dx is equal to 0. So this actually indicates where we can find maxima or minima point. Whenever your function is decreasing, it stops and then it starts increasing again, or the other way, if it's increasing, it stops and it starts decreasing, then that has to be a local point of minima or maxima, right? I hope that makes intuitive sense. So it can work the other way around. Your function is increasing, your gradient is positive, and then it becomes 0, the tangent line has a 0 gradient, and then your tangent line has a negative gradient here. Here is 0, here it's positive, here it's negative. So this is a maxima, this is a minima. Alright, so that is the idea I wanted to give you. If dy by dx is equal to 0, that indicates you either have a local minimum or a local maximum point at that place. And basically on either side, there has to be a change in your, there has to be a change. So like this, we went from a tangent line is negative, it became 0, and then it became positive, right? So there has to be a change in the increasing or decreasing nature of a function for you to consider it to be a maxima or a minima, right? You could have something like this. And in this case, your gradient is positive, it becomes 0 at some point, and then it continues to be positive. So this is, here at this point, dy by dx is 0, but it is not a local minima or maxima. So if this occurs, if you can see that your tangent line is either has a positive and then the gradient is 0 and then it becomes negative, or vice versa, then you can conclude. But if it's just dy by dx is 0, then you cannot conclude that it's a local minima or a maxima. But usually, for our questions, dy by dx is going to be a maxima or a minima, but we will always check this. We will always check for our sign change in dy by dx. Alright, but I don't think maxima and minima is covered, so we are just going to talk about increasing and decreasing functions. Alright, so now that we have done the theory part, let's look at the questions. So question for 1, I'll do A, C, and E. For 2, I'll do B, D, and F. I hope that is okay. Alright, so we want to find where the function is increasing. That means dy by dx or f dash of x is positive, bigger than 0, right? So f of x is x squared minus 8x plus 2. F of x, that is A, is equal to x squared minus 8x plus 2, right? So f dash of x, the derivative, is going to be 2x minus 8. Now let's think about this. When is f dash of x bigger than 0? Well, then that means 2x minus 8 has to be bigger than 0. 2x minus 8 bigger. If I add 8 on both sides, 2x has to be bigger than 8, right? I just added 8 on both sides, and x has to be bigger than 4. So increasing for x bigger than 4. If x is exactly 4, then it's 0, right? So you can't say anything. So for x bigger than 4, your function is increasing, strictly increasing. So for C, you have 5 minus 7x, so f of x. So sometimes you have this distinction for an increasing function is a less than b, f of a less than or equal to f of b. This is still considered to be increasing. And in this case, then we would have said x is bigger than or equal to 4, right? But our textbook follows the strictly increasing convention, which is this one. And for this convention, x is bigger than 4. So some textbooks will say that this is increasing, and this is strictly increasing. So we are going to follow the strictly increasing idea. Alright, so x is bigger than 4. So question C, f of x is 5 minus 7x minus 2x squared. 5 minus 7x minus 2x squared. So if I find f dash of x, then that is going to be minus 7 minus 4x. So I'll leave you to do the differentiation on your own because we have done so many of these. And now I need to solve f dash of x is bigger than 0. So minus 7 minus 4x is bigger than 0. Minus 7 is bigger, so minus 4x bigger than, I add 7 on both sides. Now I need to divide by negative 4. If I divide by a negative value, and I encourage you to check out my earlier videos about inequalities, but that is going to give me this. And if you solve for this, I believe you are going to get x is less than negative 1.75. That is what you should be getting. So 7 divided by negative 4 is this expression. Yeah, negative 1.75. So you have to change the direction of your inequality if you divide by a negative number. If you divide by a positive, there is no need. If you divide by a negative number, you need to change the direction of your inequality. So overall, your final answer is going to be this. And I have already made videos about solving inequalities, so I encourage you to check them out. Now, A, C, and I said I would do E. All right. So we have done A, we have done C. E is 2x cubed minus 15x squared. So f of x is 2x cubed minus 15x squared plus 24x plus 6. So now let's take the derivative. F dash of x is 8x squared minus 30x. So I'm doing it directly, but I encourage you to try it on your own, plus 24. Alright, so if you differentiate this expression, you're going to get this. And I'm not going to take the time out to differentiate it separately. I hope that you got the idea of how to do differentiation. So now that I have this, I will factor out a 2, right? Actually, yeah, I think I can factor out a 2. And I get 4x squared minus 15x plus 12. Now I need to factorize this. Alright. So now if I try to factorize out this, well, my sum is negative 15. My product is equal to 12 fours of 48. So I need to think of two numbers that when I add together, I get 15. When I multiply them, I get 48. So are there any two numbers that satisfy this condition? Unless I factorized it wrong. I don't think I did. So let's see. 48, if I divide by 2, I get 24. Doesn't help. 24, I divide by 4, I get 12. Divide by 4 again, I get 6. So 6, 8 is 48, but 6 plus 8 is not 15. That doesn't help. If I divide by 2, I get 3. So that is 16, 3. Also does not give me 15. So I don't think I can use... Okay, yeah, I made a mistake when doing the differentiation. Okay, that's why it doesn't work. Okay, I'm so sorry. So if I differentiate this, I get 6x squared. 3 2s are 6, not 8. Minus 30x plus 24. Now I can factor out a 6 actually. Alright, so I get this. I can factor out a 6 from this expression. 6 5s are 30, 6 4s are 24. Now if I factor out a 6, so I made a mistake there. I can now factorize this. And I can do it very easily. It's going to be this. Right? Think about it. So now we have done quadratic inequalities. We can solve this. So I don't need to worry about my constant factor. I have to worry about this. These are going to... Because 6 is positive. It's not going to affect anything. This will determine whether my f dash of x is positive or negative. So here gives me x minus 4 equal to 0, gives me x is equal to 4. X minus 1 equal to 0 gives me x is equal to 1. So I need to think of what values do I put in here so that I get 0. I need to put in 1 and I need to put in 4. Alright. Now imagine I put in a number bigger than 4, such as 5. Put in 5. 5 minus 4 is 1. 5 minus 1 is 4. Right? So both of these are positive, and their product is going to be positive. Positive, positive, positive gives me something that is positive. Now think of a number between 1 and 4 that is between 1 and 4. So let's say 2. 2 minus 4, that is negative 2. 2 minus 1 is positive 1. So negative, positive gives me negative. Now think of a number that is less than 1, like 0. So 0 minus 1 here is negative 1. 0 minus 4 here is negative 4. Negative 4 times negative 1 is positive. 4 times 6 is 24. So now, if x is less than 1, then f dash of here, it's 0. Right? At 4 and 1, f dash of x is 0. If x is less than 1, then f dash of x is positive, bigger than 0. If x is bigger than 4, f dash of x is positive. So these are your two. So you can write your final answers, x less than 1 and x bigger than 4. Alright, so sorry for the first time I differentiated it wrong. So we're done with question 1. Question 2. Find the set of values of x for which each of the following is decreasing. Alright. So f of x, 10 plus 9x minus x squared. So decreasing means f dash of x is less than 0. So that is something we have to remember. So f dash of x is going to be 9 minus 2x. If you differentiate this, you're going to get this. So I need to solve for f dash of x is less than 0. 9 minus 2x is less than 0. 9. So I can send 2x. I can add 2x on both sides. I get this expression. Now 9 over 2. So I can divide by positive 2 without changing the direction of my inequality. And finally, I get x is bigger than 4.5. So that is the solution. Or you can write it as x bigger than 4.5. It means the same thing. These are the same thing. So that is B. For D, it's exactly the same thing. Solve x cubed minus 3x squared minus 9x plus 5. So f dash of x is going to be 3x squared minus 6x minus 9. You can factor out a 3 here. And then you can factorize this. So when you factorize it, you are going to get x minus 3, x plus 1. And we have discussed factorization, we have discussed differentiation before. So that is why I'm doing it very quickly. And now I can draw a number line. What number do I put in here? So number line has to be in order, right? It has to be increasing as you go to the right. If I put 3 here, positive 3 gives me 0. If I put negative 1 here, that is going to give me 0. And how do I know? Well, x minus 3 equals to 0. I'm just going to solve this. And whatever answer I get, I'm going to put it on my number line. Alright. So now I will leave you to figure it out, but you are going to get this pattern. How? If I put in a number bigger than 3, say 4. 4 minus 3 is 1. 4 plus 1 is 5. So that gives me something positive, right? These three things multiplied together, my answer is positive. And it's going to be true for all numbers bigger than 3. If I put in something less than negative 1, say negative 2. Negative 2 minus 3 is negative 5. Negative 2 plus 1 is negative 1, right? So negative and negative. So that gives me something that is positive. Positive, negative, negative is positive. Now put a number between negative 1 and 3. Say 0. 0 plus 1, positive. 0 minus 3 is negative. This is positive. So positive times positive is going to give me something that is negative. So therefore, my f dash of x is less than 0, which means that the function is decreasing when x is bigger than negative 1, which basically means x is in this range, right? And is less than 3. That is your answer for D. And it's not exactly negative 1 or 3, because f dash of x is equal to 0 at those points. At this point, dy by dx, or f dash of x, is 0. Alright. So we are done with B and D. So let's do F. For F, we have f of x is equal to 11 plus 24x minus 3x squared minus x cubed. F dash of x is going to be 24 minus 6x minus 3x squared. So I'll leave you to do the differentiation on your own. Now I can factor out a negative 3. It's easier if you factor out the negative 3. Why? Because then you have x squared plus 2x plus 6. Sorry, minus 6. Minus 8, I think. So if you factor out the negative 3 from this, you are going to get this expression. And it's easy for me to factorize this. If I took out only a 3, then I would have minus x squared and something, and that is harder to factorize, right? So now if I had to factorize this, I'm going to get... These are going to be my factors. X plus 4, x minus 2, right? Yes. So now let's draw our number line. And using these 2 points, I know that 2 and negative 4 are going to be on my number line. Now, if you solve it, so now think about it. Put a number bigger than 2. So let's say 3. 3 minus 2, this is 1. 3 plus 4, this is 7. And this is negative 3. So positive, positive, negative is going to give me negative. Let's repeat. Put in a number between, this is negative, right? Negative 4 and 2. Put in 0. This is going to be negative 2. This is going to be 4. And this is going to be negative 3. So negative 3 times 4 times negative 2, that is going to give you a positive answer. Now put in a number less than negative 4. Say negative 5. Negative 5 plus 4 is negative 1. This is negative 7. This is negative. Overall, your answer is going to be negative. Negative times negative times negative is going to give you negative. Alright, so now we need to find when f dash of x is decreasing, when dy by dx is negative, right? So x has to be less than negative 4 in this region, or x has to be bigger than positive 2. So that is going to be your solution for question D, F. And we are done. Now let's look at question 3. We need to find the set of values for which, this expression is increasing. So we have f of x is equal to 1 over 6, 5 minus 2x cubed plus 4x. Now let's differentiate this. F dash of x. 1 over 6 is a constant. I keep as it is. 3 will come to the front, right? 3 times 5 minus 2x squared, because 3 minus 1 is squared. But ani x dega? No. So you have to differentiate it again. So now we've differentiated only the first term. Remember, we also need to differentiate 4x, and that will give me 4. So this is just 1/2 5 minus 2x squared. And if you differentiate this, this is going to be minus 2 plus 4. And remember, these are going to cancel out. So you have minus 5 minus 2x squared plus 4. And now we can write this as 4 minus 5 minus 2x squared. So now we need to check when f dash of x is bigger than 0, right? That is when the function is increasing. So 4 minus 5 minus 2x squared is bigger than 0. And I can add this expression to both sides. So I will get 5 minus 2x squared. So now, if you have this situation, let's think about it. We need to know that when we square a number, that has to be less than 4, right? So one possible value is that if 5 minus 2x is less than positive 2, right? So if I just take the square root, positive square root of 4, then it works. Why? If it's less than 2, then I square this, my answer is going to be less than 4. Definitely, right? So if this is the case, then if I square this, if I square both sides of my inequality, then it has to be less than positive 4. So that is one possible solution. And another possible solution is that 5 minus 2x is bigger than negative 2. Sorry, it's less than negative 2, right? That should also work. Why? Because if it's bigger than negative 2, not less than. Because if it's bigger than negative 2, say negative 1, something like 0, then if I square that, then in this case as well, so these are the two possible expressions that I can get out of this. So either if my 5 minus 2x is less than 2, then its square is less than 4, or it has to be bigger than negative 2. Then as well, its square is going to be less than positive 4, because negative 2 squared is positive 4. If you choose a number less than negative 2, like negative 3, the square is going to be positive 9, right? So that is why you can't choose any number that is less than negative 2. So we are going to solve these two inequalities. So now, if I subtract 5 from both sides, I get this expression. Now if you want to solve this inequality, you actually have to do this. If you cancel out the negative signs, you have to remember, you have to switch the sign of your inequality. So you get x is bigger than 1.5. And from this expression, if you subtract 5 on both sides, you get this expression. And basically, if you cancel the negative signs out, you have to switch the signs. And I divide by 2, I get x is less than 3.5. So now, putting everything together, I get x is between 1.5 and 3.5. That is your solution for C. So I encourage you to watch my videos about inequalities, and let me just briefly discuss something about this. So let's say 5 minus 2x is equal to u, and I need to solve for u square is less than 4. So let me explain this using the number line. Let's say this is 2. This is negative 2, right? 2 squared, because 4 is just 2 squared, right? So the idea is that, hey, if I have 2, if I pick a number bigger than 2, if u bigger than 2, then u squared is bigger than 4. Definitely, right? So squaring u is going to give me something that is bigger than 4. See, if you pick u such as 3, then 3 squared is 9 is bigger than 4. But the same thing applies if u is less than 2. If u is negative 2, then u squared is 4. Then u squared is 4. But if you pick something less than negative 2, such as negative 3, then negative 3 squared is positive 9, and 9 is bigger than 4. So your number has to be in between this. So u has to be bigger than negative 2, but it has to be less than positive 2. And that is what we did with u is just 5 minus 2x. And now if you solve, you get, if you subtract 5, you get this expression. Now you cancel out your negative sign, but remember, you have to flip your inequality. And if you divide, you get this expression, which is exactly the answer that we have here. It's just I've represented it in a different direction, but it's the same answer. So x is bigger than 1.5 is less than 3.5. So that is the idea that we have used for question 3. And we are done. Question 4. A function f is defined as f of x is this expression for x is bigger than or equal to 1. So we need to first of all find f dash of x and determine whether it's an increasing, decreasing, or a decreasing function. Alright, so we have f of x 1 minus 2x. If you want to find f dash of x, first of all, let me write this as 4 times 1 minus 2x to the power negative 1. So let's try to find f dash of x. So that is going to be 4 times negative 1, and then 1 minus 2x to the power negative 2. Right? This is the formula, using the formula. But ani x tega made, so you have to differentiate it again. And if you simplify, you are going to get negative 4, 1 minus 2x to the power negative 2. And then if you differentiate this, you are going to get negative 2. And you are going to get overall 8, 1 minus 2x to the power squared. Okay, so this is your f dash of x. And for x bigger than or equal to 1, so you put in 1, your numerator is always going to be, so if you put in x half, then it's going to be 0. So x cannot be equal to half. But it says x is bigger than or equal to 1, so it's fine. So for x is bigger than or equal to 1, your numerator is positive. 8 is always, we have positive 8. Your denominator is also positive. Therefore, overall, f dash of x is bigger than 0. So your function is increasing. For x is bigger than or equal to 1. I'm so sorry, the dogs are howling outside. So it's an increasing function. So this is your expression. Alright, so we're done with question 4. Question 5. A function f is defined as this expression. Okay, it's the same question basically. So f of x is equal to 5 divided by x plus 2 squared minus 2 over x plus 2. So let's write this in a form where we can use our power rule easily. So x plus 2 to the power minus 2 minus 2, x plus 2 to the power minus 1. So I can write this expression like this. So now let's find f dash of x. So 5 minus 2, x plus 2 to the power minus 3. Ani x dega made, but if you differentiate it, you are going to get times positive 1. So we don't need to worry about that. Minus 2, you bring your negative 1 to the front, you have x plus 2 to the power negative 2, but ani x dega made, so you need to actually differentiate. So this is going to be a multiplication sign every time you use the chain rule, but when you differentiate it, you are going to get positive 1. So you overall, now I leave you to simplify this, but you are going to have this expression. This is going to be your expression. And now we need to simplify this. So if I multiply, and if I divide by, so if I multiply both my numerator and my denominator by x plus 2, I get this expression. And now I can combine my numerator together, and I will get this expression. I think. Yeah, this should be it. Alright, so we have this expression for f dash of x for x is bigger than or equal to 0. So if x is bigger than or equal to 0, then our denominator is always positive, right? You put in something bigger than or equal to 0, you'll get a positive denominator. So now, let's think about our numerator. If I put in 0, then my numerator is negative, my denominator is positive. So overall, f dash of x is negative. But if I put in x is equal to, say, 6. 6 2s are 12, right? 12 minus 6 is, so if I put in x is equal to 0, because it says x is bigger than or equal to 0, right? So if I put in x is equal to 0, I get numerator is negative 6, which is negative. I get denominator is equal to positive 8. So this is overall going to give me f dash of x negative. And if I put in 6, I get numerator is positive 6. And my denominator is going to be 8 cubed. Numerator is going to be positive 6. So this is f dash of x positive. So we are going to get neither. It is neither increasing or decreasing for this big restriction. So it's not completely an increasing function, it's not totally a decreasing function. There is an interval for this function where it can be either increasing or decreasing, but we are going to say neither because it's not strictly increasing in that restriction or it's not strictly decreasing in that restriction. Alright, so question 6. Show that this expression is an increasing function, and we just need to show that f dash of x is bigger than 0. So we are given x squared minus 4 divided by x, right? So this, I can write this as x minus 4 to the, I can write this like this. How? Well, x squared divided by x minus 4 over x. Now this part I can write as x, and this part I can write it as 4 times x to the power negative 1. So now let's find f dash of x. Differentiate x and you get 1. And now let's differentiate this expression. So I have 4 minus 1 comes to the front and this. So now I will get 1 plus 4 over x squared. And for any x squared is bigger than or equal to 0. Right? And there should be a restriction here because x, your denominator can never be equal to 0. So x does not equal to 0. Therefore, x squared is positive if x does not equal to 0, right? Think about it. You square any number, you are never going to get something that is negative. And this is something that we have talked about in when we did domain and range of functions, right? F of x is always bigger than or equal to 0. The range of the squared function is all output values, right? X squared is going to be greater than 0 if x is not equal to 0. So this is always going to be positive. This is positive. So overall, f dash of x, if x, and therefore 4 over x squared is bigger than 0, and 1 plus 4 over x squared is bigger than 1 is bigger than 0. So that means that f dash of x is bigger than 0. That means it's an increasing function. And it's always going to be an increasing function because we have proved that it's for any x. Alright. So we are done with question 6. Question 7. We are given f of x and we need to explain why it is an increasing function. So basically you have 2x plus 5 squared minus 3 for x bigger than or equal to 0. Take f dash of x. For the first term, 2 comes to the front. You have 2x plus 5 to the power 1. But ani x tega, made, so you need to differentiate it again. And if you differentiate this, you get 0. So the derivative, from this side, you are going to get 2. So overall, you are going to get this expression. And for x bigger than or equal to 0, 4 times 2x plus 5 is going to be bigger than 0. You put 0 here, 5 4s are 20. You put any number bigger than 0. This is positive, this is positive. So overall, this is going to be positive. And therefore, f dash of x is equal to bigger than 0 for x bigger than or equal to 0. Hence, increasing. So this is how you can explain it. If you find f dash of x, you get this expression. And for this restriction, this expression is always bigger than 0. And you can check. You put in 0, you get 20. You put in any value bigger than 0, you always get something that is positive. So now f dash of x is bigger than 0 for this restriction. Therefore, the function has to be increasing. All right. So 8, it is given this expression. We need to show that it is a decreasing function. 2 over x to the power 4 minus x squared. And now let's find f of x is equal to 2 x to the power minus 4. So we write it as this, right? So now let's find f dash of x. 2, you bring minus 4 to the front, x to the power minus 5, right? Minus 4 minus 1 is going to give you minus 4. You have minus 2x when you differentiate this. So you get minus 8 divided by x to the power 5 minus 2x. Or you can write this minus 8 over x to the power 5 plus 2x. So for x bigger than 0. So now think about this. If x is bigger than 0, this is positive because 2 times something positive is going to give you positive. And this is positive because x to the power 5 is going to be positive, right? Positive number raised to the 5th power is positive. So this expression is always positive for x bigger than 0. And when you multiply by negative, overall, 8 over x to the power 5 plus 2x is bigger than 0 for x bigger than 0. But we have a negative sign. So if I multiply both sides by negative 1, I get this expression. And don't worry, this does not change because this is our restriction, right? But remember, this is our f dash of x. Is less than 0. And therefore, it is a decreasing function for all x bigger than 0. Alright. So that is the idea. Because this expression, which is f dash of x, is less than 0, then the function is decreasing. So we are done with question 8. Question 9. So a manufacturing company produces X articles per day. This is the profit function. 2x cubed minus 81x squared plus 840x. Find the range of values of x for which the profit is decreasing. Alright, so just differentiate your profit function and you are going to get 6x squared minus 81 times 2. That is going to be 162x plus 840. So you are going to get this expression if you just differentiate it. Now I believe you can factor out a 6. So if you factor out a 6, you get this equation. And now we need to factorize this. So now, to factorize this is not going to be easy. So because we need to think about two numbers that give me the sum negative 27 and the product 140. All right. So 35 times 4 is 140, but that does not help. Let's see. 14 times 10 is 140. That does not help. 7 times 20. Yes. So that is going to be our two values. 7 times 20. That is going to give me 140. And actually, if I take negative 7 and negative 20, if you multiply these together, you are going to get 140. If you add them together, you get negative 27. That is correct. So you get negative 20x minus 7x plus 140. So 6, I factor out in x here, I get x minus 20. I factor out in negative 7 here, I get x minus 20. So you can use any method that you want, but you are going to get x minus 7, x minus 20 when you finish simplifying this. And now you can draw your number line. And when you draw your number line, and I'm going to leave you to try it on your own, you are going to get this, plus minus plus for p dash of x. So we want to find when the profit is decreasing, right? So the profit at this point is going to be 0. Remember, at this point is going to be 0 because if you plug in 20 and 7, you're going to get 0. So x is bigger than 7, is less than 20. Here, the profit is decreasing. Why in this range? Because in this range, p dash of x is less than 0. And if the profit function is negative, that means the profit function is decreasing. So this is your solution, and we are done with this topic.